Hello, grade 10s. Welcome to your exam school revision show with myself, Queen. Now, I'm not alone. Of course, we've got a lovely teacher with us in studio. Tamlin, how are you,
Hi,
Tamlin?
I'm well. How are you?
I'm well, thanks, Tamlin.
Good.
So, can you just let the grade 10s know exactly what we'll be going through for today's show?
Okay, well, as exams are approaching for the grade 10s as well, today we're going to be focusing on the content that you should be looking at for paper 1. So, obviously not everything, but we're going to try and pick out a few important concepts and see if we can just revise those today.
All right, so guys, if you have any questions along the show, just be sure to connect with us on Facebook or Twitter. Just send through your questions and we will try to answer all of them to the best of our ability. And remember, guys, if you also want to catch some other resource materials that you can use to help you, just go onto our website on mindsetlearn.co.za, and then there we've got everything for you. So let's not waste any more time. Tamlin, let's continue the show.
Right, grade 10s, I've got lots of revision for you, so I hope you've all got your pens, your paper, your calculator out, and you're ready to work. Okay, a lot of this stuff you have obviously seen during the year, so now it's a case of just reminding ourselves how it all works. So as we've mentioned, it's all paper 1, all right? So please just make sure you familiarize yourself with what is in paper 1, all the different sections. Probability, which is in paper 1. A lot of people sometimes get confused with that. It is paper 1. Functions, factorizing, simplifying, all of those things, equations, that's what we're going to be having a look at today. Okay. Right, before we get going, we're going to have a quick look at our challenge question. All right, so I've chosen a nice probability question for you. Many of you have probably recently covered this in class, so let's have a look and see how you manage with this, okay? Very briefly, at a school, there are 200 learners in grade 10. Out of the students, okay, we've got 107 who take just history, 63 who take science, 90 who take biology, 23 who take history and science, 35 who take history and biology, 190 take history or science or biology, okay? 15 learners take all 3 subjects. And here's a nice hint for you. They want you to let the number of learners that take science and biology but not history to be the value of x. Okay, so guys, what you're going to do with this information is you are going to first of all plot a Venn diagram, okay? Remember your circles, you've got 3 different subjects, so my first hint to you is you've got 3 different overlapping circles, okay? So I want you to read very carefully through the information given. And another small hint, just to set you on your way, start at the bottom, okay? Start with the information regarding where x is and work your way up, and actually you'll find that it actually is not as bad as a lot of you seem to think it is. Okay, right, so that's your challenge question. And in the meantime, we're going to move on to some typical algebra and some typical questions you can expect in your exam. Okay, so one of your typical instructions that you'll get in an exam is to simplify, all right? Simplifying is asking you to get rid of any brackets that you have in your sum and reduce your sum down to as simple a form as you can get it to, okay? So, right, this first question, I chose it because it's a lovely question that a lot of people make a really typical mistake in. And the typical mistake with question A is as follows. A lot of people look at this and say, right, 2x minus 3 all squared. Here's the mistake that gets made. They take the 2 and they square the first term and they square the second term and they say the answer is 4x squared plus 9, and they think, great, let's move on, okay? The reason that is wrong, grade 10s, and please take note of this, it's a heartbreaking question when you guys get this wrong because it's not necessary. This is incorrect, okay? What we want you to do is this. If you have got a bracket of 2x minus 3 squared, anything squared means you are multiplying it by itself 2 times, okay? So I'm taking the bracket of 2x minus 3 and I'm multiplying it by itself twice, which means that we are going to have to use our good old FOIL. Okay, we're going to multiply it out. Firsts, outers, inners, last. So first is going to give us 4x squared. Outers is going to give us negative 6x. Innes is also negative 6x. So when I add like terms, you're going to get negative 12x. And then negative 3 times negative 3 is going to give us positive 9. So guys, you are not allowed to make that mistake. Please be very careful that a bracket squared, you must FOIL it out. Okay, right, there we go. Second question. We have got 3x minus 1 squared minus 2, and then we've got the two brackets multiplied together. So I'll throw this in because here again is our concept of squaring that bracket. And then we also have a bit of FOIL to do over here. And BODMAS, okay? We're having to follow the rules of BODMAS here in that we're going to have to get the multiplication and the exponents done first before we do any addition and subtraction, okay? Right, so first things first, I have got 3, and this bracket of x minus 1 squared, if we FOIL that out, we're going to do our firsts, which is x squared, outers, which would be negative 1x, inners, which would be negative 1x, so we're getting negative 2x, and your lasts would be positive 1, okay? What I have done there, grade 10s, is I actually did that FOIL by inspection. I did it in my head, okay? Now, you don't have to, all right? You can write the brackets out twice, as I did over there, and you can actually go through the steps of FOIL, but it does help you for time management to learn to do those kinds of things by inspection, which is in your mental calculations, okay? So please try practice that because it will help you just get things working quickly, okay? All right, so that's the first thing. Then I've got negative 2. The next thing that needs to happen here is we need to FOIL those two brackets out. So inside this, we're going to say I've got 2, x squared. Outers is negative 1x. Inners is positive 6x, so therefore I'm going to be left with positive 5x. And last is going to be negative 3, okay? Now that I've gotten rid of the brackets, the next thing to do is to distribute, all right? We're going to distribute the 2, but please make sure that you are careful. It's not just 2, it's negative 2 that is being distributed. So we are going to have 3x squared minus 6x plus 3 minus 4x squared minus 10x plus 6. Okay, so I have now FOILed out the brackets, I've done all the multiplication, I've done the distribution, so the last thing left to do is to add like terms. All right, we're only allowed to add like terms, so therefore the x squareds can get put together. That means that I've got 3x squared minus 4x squared, which is leaving us with negative 1x squared. I've got a negative 6x and a negative 10x. So negative 6 minus 10, that's giving us negative 16x. And I have got a constant of 3 and plus 6, so therefore we're left with plus 9. Okay, and guys, we can't go any further than that, so you have simplified fully. All right. All right, last question here. Now, this is a nice question. I'm just going to erase, actually, oh, whoopsie. I'm going to erase that. Okay, never mind, I won't do that now. Okay, what I want you guys to please look at very carefully is question C. We've got a bracket of 2a minus 3b. I've got a bracket of 8a cubed plus 27b squared, b cubed. And 4a squared plus 6ab plus 9b squared. Now, we're needing to multiply this all out, and I'm sure you guys will agree with me that if I start with distributing the first bracket into the second bracket and then distributing the second bracket into the third bracket, we're going to sit with a massive calculation over here. So maybe there's a chance that there's a trick here. And if you look carefully enough, there is. You just need to spot it, okay? Do you remember learning the rule of your sum or difference of two cubes? Okay, sum or difference of two cubes, let's remind you quickly. I'm going to give you a quick example. I'm just going to quickly put it in over here, okay? Sum or difference of two cubes says this. If I've got 27b cubed minus 8b cubed, just as an example, okay? The way we're going to factorize that, you would have a binomial bracket and a trinomial bracket. And your starting point is we're going to take the cube root of 27, which is 3, cube root of b cubed, which is just b, minus the cube root of 8, and then b. Okay, so what I've done is taken the cube root of that entire first bracket. To find the second bracket, we now do the following. We we take the first term of 3b and we square it. So I get 9b squared. I take the second term, which is negative 2b, and again I square it, which is going to give me positive 4b squared. All right? Then to get this middle term over here, we need to find the product of the first two terms in the bracket here, which means I'm going to say 3b times by negative 2b, okay? And that's going to become 6, and I'm going to write it as just b, not b squared, because I want the second bracket to go in sort of descending powers. So I shouldn't have used b there. Sorry, that was a silly mistake. Let's just change that to a c. Okay, that would be c. So that would be c, and that would be c. Sorry, it wouldn't ever be the same variable. And just finishing off, so therefore it would be bc inside the bracket over there. And just to watch out that if this is a minus, your middle term would always be the opposite. So in that case, it would change to plus. Okay, so using that as just a basic example, now let's look at this. If I were to focus on this first bracket and this third bracket over here, let's see if there's some kind of relationship happening over here. If I took the first term of 2a and I squared it, I would get 4a squared. If I took the second term of negative 3b and I squared it, I would get 9b squared. Okay, so the rule looks like it's working. If I multiply the two terms inside that bracket together, I would get a 6ab, which I have over there, 6ab. And here's a negative, and this is the opposite, which is positive. So the trick here, guys, is that you're supposed to spot that the two outer brackets are, in fact, a difference of 2 cubes, okay? And the shortcut of difference of 2 cubes is to get, to simplify it, all you have to do is multiply the first two terms together and the last two terms together. That's all you have to do, all right? So to simplify these two outer brackets, I would multiply the first two terms together, which is going to be a 2 times a 4, which is going to give me 8 cubed. And negative 3 times 9 is 27, negative 27, b cubed. And then the other bracket, which we haven't used yet, is this middle one, which is 8a cubed plus 27b cubed. Okay, and looking at what we have left, 8a cubed minus 27b cubed multiplied by 8a cubed plus 27b cubed, well, what I hope you're spotting there is the difference of 2 squares, okay? And again, difference of 2 squares, to simplify, we just need to multiply the first two terms and the last two terms. You don't need to waste your time with anything else. So therefore, our answer, our simplified answer, is 64, a to the 6, minus, okay, 27, let's just clear this up over here, 27 squared, we get 729. 729 b to the 6. So what looked like an enormous sum to simplify actually worked out really small, as long as you spotted the shortcut there. So please learn your difference of 2 cubes rule, guys. It's a new one that you learned this year, and obviously I'm sure it will come up in your paper. All right. Okay, so that was simplifying. All right, now the reverse of simplifying, getting rid of the brackets, is going to be to factorize, which is taking your expression and putting it into brackets. Simplifying and factorizing are the absolute reverse process of each other, okay? Now, factorizing involves steps. Step 1, you always check to see if you have got a highest common factor first, okay? That's step 1. Step 2, you ask yourself how many terms you have got in your expression. If there's only 2 terms, a difference of 2 squares is what you need to look out for, or possibly or some a difference of 2 cubes. If there's 3 terms, you're looking for a trinomial, and 4 terms, another new concept you learned this year, grouping, okay? So those are the different steps that you have to actually look and follow when we're looking at factorizing. So let's see over here. We need to factorize. My instruction is to factorize the following. So looking at A, step 1. If I've got 8x squared, I've got 18xy and negative 5y squared. Let's go through our checklist. Do we have a highest common factor? No. How many terms do we have? I've got 1, 2, 3 terms, so we know we've got a trinomial. The tricky part about this trinomial is, in fact, that we have got a constant, or we've got a coefficient in front of your x squared, and that makes your trinomial a little bit more tricky to factorize, okay? The way I go about doing it, I know there are different methods that you might have learned. This is a method that I use, but you can use whatever you use at school. As long as you're getting the right answer, we are happy. Right, factors of 8. Factors of 8, I can either say is 8 and 1, or I can say is 4 and 2. Okay, so we take the factors of the first term, and then I take the factors of the last term. Factors of the last term is just 5 and 1, okay? Now, I call this at school, I tell the students that this is called the tennis method, because what we're going to do over here is we're going to play tennis with the terms, okay? And when we play tennis, we have to serve across. So all the terms are getting served across like that, okay? One quick thing is that if I've got 5 and 1 as a factor, what you need to do is please flip them around and just change it as 1 and 5 as well. The reason being, you want to try and get all your different combinations, okay? All right, now we need to play tennis. And the magic number, the number that we're trying to get to is this one in the middle there, 18. Okay. So let's see, if I took 4 times 5, 4 times 5 is 20. Okay, and if I took 2 times 1 is 2, well, do you guys agree with me that if I took a positive, if I made the 20 positive and I made the 2 negative, then I would land up with an 18, which is exactly what we have over there. We want the 18 over there. So there we go. That's the combination that we want to work with. So what I'm going to do is I'm going to put a bracket around the top combination and a bracket around the bottom. And that, guys, is going to be your 2 brackets. I've got 4 and I've got 1. Those are the 2 numbers in your first bracket. I've got 2 and I've got 5, and those are the numbers in your second bracket. Both of them have an x. Both of them have a y, and we want the 20 to be positive. Well, 4 times 5 gave you 20, so therefore that needs to be a positive 5, where that needs to be a negative 2. Okay, a really important grade 10 concept that you need to be really familiar with, because it actually becomes important moving forward. Okay. All right, guys, we are really due for a break.
Yes, guys. Okay. Let's take a quick ad break, and then we'll see you guys when we come back. Welcome back, grade 10s. You are still with us here on the Exam School Revision Show, and we are busy with mathematics. And if you've just joined us, don't worry, we're not that far into the show, so I'm quite sure that you can still catch up with us. We've got Tamlin, so Tamlin, let's continue with the show.
Thanks, Queen. Okay, so we were just working on some factorizing, so let me do one more example of that, and then let's get on to some fractions. Okay. Let's look at question B. We're being asked to factorize 72 minus 8a squared. So go through your checklist. Do I have a highest common factor? Well, in this case, yes, I do. I've got a common factor of 8. Okay. If I take out 8, I'm left with 9 from my first term, and I'm left with a squared from my second term, which, guys, I'm sure we all recognize that as being a difference of 2 squares. Okay, so 3 minus a and 3 plus a. All right, guys, I'm going to leave you guys to go and have a look at question number 3. The answers are posted on the website. Go and have a look at that. Try it. It is quite a tricky one, so I would like you to go and have a look. But in the meantime, we need to have a look at some fractions. Okay, 2 types of fractions that we're going to expect in our exam: an addition or subtraction, and then a multiplication and division. Okay, so very first thing we have a look at is addition and subtraction of fractions. And we go back to basic laws of fractions here, that if we are adding or subtracting a fraction, we find a lowest common denominator. Okay, so first things first, let's find our LCD. So I'm going to draw myself my division line. And we've got what? I've got a denominator of 3, of 3, and of 12. So what is the lowest number that 3, 3, and 12 will all go into? I'm sure you all agree with me. It's going to be 12. Okay? Now we go to the next really fundamental rule of fractions. What you do to the bottom, you do to the top. Okay? So what did I multiply 3 by to get to 12? I times it by 4. Which means that this numerator is also going to get multiplied by 4. What did I times 3 by? I also multiplied that by 4, which means that this is also going to get multiplied by 4. So therefore, that's going to become a negative 8 outside the bracket. And we've got our a plus 1. And here's a little tricky part, okay? What did I times 12 by to get to 12? I multiplied it by 1. And what I do to the bottom, I do to the top. Now this negative belongs to that whole term of 3 minus 5. So the negative is going to distribute into the bracket, and we need to be careful of that. So the negative is sitting outside the bracket, and I've got a 3a minus 5. Okay, now let's simplify. I'm going to distribute my 4 into the bracket, giving us 4a minus 12. I'm going to distribute, giving us minus negative 8a minus 8. And negative 3a plus 5, and that's all sitting over the LCD of 12. We don't drop that LCD. It is not it's not an equation. That's the only time you are allowed to drop the LCD. Now we add our like terms. I've got a 4a minus an 8a, that's negative 4, minus 3, which is giving us negative 7. Negative 7a, and I've got a negative 12 plus a 5, so that's going to leave us with negative 7 over 12. Oh no, and I missed the 8 as well, sorry, whoops. Okay, so let's just quickly see. That's going to give us negative 15. Sorry, negative 8 minus 7 is minus 15 over 12. Okay, so a couple of things there. First of all, you find the LCD. That's the first step. What you did to the bottom, you do to the top. And a safe thing is to put each of the existing numerators in brackets and then put what you're multiplying it by outside that bracket so that you're aware that it needs to distribute. Okay? And the third thing, guys, is please don't drop the denominator. Unfortunately, you start blurring the lines between the rules of equations and just the rules of fractions. And in this case, that denominator doesn't go anywhere. All right, so it stays there. Okay. Then let's do some multiplication. Okay, it looks complicated, but we just have to take it one step at a time, and then it's not too bad. Okay, a whole lot of factorizing needs to happen here. Multiplication and division do not require an LCD. Okay, what they require is cross multiplication and cross cancelling. All right. So first things first, it's factorizing. So can you see it's a very different approach that we have to the adding and the subtracting. How am I going to factorize this numerator? Well, that is a trinomial. And as a trinomial factorized, I'm going to have an x and an x. My factors of 6, I'm going to have to say 3y and 2y, and both of them are going to have to be positives. Okay? That is then going to be over the denominator of, I've got this one over here, x squared minus 36, that's a difference of 2 squares. Minus 6 plus 6. Okay, let's take a quick look at this divide. What do we do when we are dividing fractions? Okay, I'm sure we've heard the nickname, we tip and times it, all right? We change the divide to times and we invert the fraction. So therefore this divide is now going to be times, and this fraction now gets inverted, which means that the numerator is now going to be factorized as a trinomial, which is going to be x and x. 18, 6 times 3 is 18, where negative 3 plus 3 will give you the, negative 6 plus 3 will give you that negative in the middle there. That's going to be over then the denominator, which is now what was the numerator, and there's a highest common factor of 3 that can come out of that, leaving us with an x plus 3y. And finally, okay, that third operation is already timed, so that's going to stay as it is. I've got an x plus 6, and I've got an x plus 2y. Okay, so now that we've done all of that, now we look for common brackets, and we look to cancel. So for example, 3x plus y, 3x plus y. As long as you're cancelling a numerator with a denominator, you are safe, okay? X minus 6, x minus 6. I've got an x plus 6 and an x plus 6, an x plus 2y and an x plus 2y. That's leaving me with this bracket up here of x plus 3 and that little term of 3 down there. So our simplified answer is x plus 3 over 3. Okay, so please make sure you factorize everything carefully. That's worth a lot of marks, okay? There's a lot happening over there. So factorize carefully. Make sure if there's a divide that you invert your fraction and you change it to times, and then you can cross-cancel. As I've said before, it doesn't require an LCD because it's not addition and subtraction. All right, so I hope you understand that. As I say, that's worth a lot of marks and a pretty sure question that'll come up in that paper of yours. So please go practice those, okay? Okay, guys, then equations. Okay, so in our exam we have simplified, we have factorized, we've done our algebraic fractions. Guaranteed we're going to be asked to solve for x or whatever the variable happens to be. Okay, so we've learned a whole lot of different equations this year. We've learned about linear equations. Then we spoke about quadratic equations. I hope these are all sounding familiar. Then we spoke about exponential equations, literal equations, and simultaneous equations. Okay, so there were a lot of different types of equations. And guys, you need to be familiar with all of them. You need to identify what makes an equation linear, what makes it quadratic. Okay, these are things you've got to be able to do. So, starting off with question 1 over here. I have got a fraction as the first term, 6x minus 3 over 5. Then I've got minus 3x, and I've got equals negative 15. Now, the first thing I say to this, if we're sitting at school and we're sitting at a desk, and every time you put your elbow on the desk, the table wobbles a little bit, all we want to do is just balance everything. So we take a piece of paper and we fold it up and we put it underneath the leg of the chair, and then everything's balanced and we're happy. Okay? That's what I want you to think of over here. This is an imbalance. This is a table that's wobbling. Okay? So let's balance it. All right? We're going to take our piece of paper and we're going to balance it under there by putting it over 1. And we're going to balance it over there by putting it over 1. Okay? Now everything is balanced. Now that we've got that, I'm sure what jumps out at you is that you have to find a common denominator, which I think is quite clear is 5. Okay. So on both sides of your equal sign, you are going to have to find your LCD, which is 5. And again, the rule applies. What I multiply to the denominator, I have to multiply to the numerator. So therefore, that 1 is going to then, well, it's going to stay 6x minus 3. This over here got multiplied by 5, so therefore negative 3 times 5 is negative 15x. Okay, and on this side, times by 5. Okay, so negative 15 times by 5, we have got, let me just make sure I don't make any, oopsie. 15 times by 5, and we've got 75. Okay, just to make sure. All right, so we've got negative 75. All right, it's at this point here. This is where I don't want you to confuse the two. At this point over here, the denominator will cancel each other on either side. So the denominator essentially falls away, okay? Only there. So only when there's an equal sign between the two denominators can you drop it, not anywhere else, okay? Now let's add like terms. That's going to give us, I've got 6x minus 15x. I'm going to have, let me just think about that for a second. 15 minus 6 is 7x. Am I right? Sorry, I'm having a complete blank there. Where's my 15 minus 5 is 10. 9, sorry. Negative 9x. And I've got, that's going to give us 75. Bring 3 over is going to give us negative 72. So therefore, if I divide by 9, I'm going to land up with 8. Okay. All right, so my x was equal to 8 over there, and that was linear. Okay, there were no x squared, so it was a pretty straightforward question. Just bringing in that element of the denominator, which you had to watch out for. Okay. All right, then we bring in the x squared. Okay, so this is now most definitely your quadratic equations. Okay, quadratic equations, they require us to follow a couple of steps. First of all, they need us to have everything on the left-hand side. Secondly, they need us to factorize what is on the left-hand side. And then thirdly, we need to solve for x for each bracket of the factorized answer. Okay, so I need that 2 to join my terms on the side. So I've got 6x squared plus 7x, and I've got plus 2, which is equal to 0. And now everything is on the left-hand side, so that's great, that's done. Now I have to factorize my left-hand side, okay? Remember my method, you've got to watch out, because there's a term in the front, because there's a coefficient at the front as well as a constant term at the back, we have to be careful how we factorize it. The factors of 6 are 3 and 1, or 6 and 1, or 3 times 2. Factors of 2 are 2 times 1, and I'm going to turn it around and say 1 times 2 just to make sure that I've got all my combinations. And now we cross multiply. So 3 times 1 is 3, 2 times 2 is 4. And 3 and 4 together will give me the 7 that we are looking for. So we bracket those two terms, and we bracket those, and we put them inside. So I've got a 3x and a 2. I've got a 2x and a 1. And everything here is positive. And let's not forget that it is still equal to 0. Okay? And the last step of a quadratic equation is to take each part of your factorized answer, so to each bracket. So I'm going to take the 3x plus 2, and I'm going to make that equal to 0. Or I'm going to take the other bracket, which was 2x plus 1, and I'm going to let that equal 0. And I'm going to solve for x in each bracket. So therefore, I'm going to bring the 2 over, and I'm going to divide by 3. Okay, and I'm going to bring the 1 over and divide by 2, and we get negative a half. So in that case, different to a linear equation, your quadratic equation, you landed up with 2 answers for x, not just 1. Okay, so linear, you will always land up with 1 solution for your variable, whereas your quadratic, you will land up with 2 because of your x squared. Okay, so please recognize that, grade 10s. Again, most definitely coming your way in your exams. Okay. All right, then we have got inequalities. Okay, inequalities are always nice, and these are your friendly ones. They're always quite nice to work out. Again, just watch out for a couple of rules, okay? We solve it, particularly a linear inequality, which is what we work with this year. We don't actually work with quadratic inequalities this year as part of the syllabus. Linear inequality gets treated typically like a linear equation to start off with, okay? We're going to bring all the variables to the one side and constants to the other, which means that I'm going to land up with negative 10. And then I'm going to need to get x on its own. So I am having to divide here by negative 5. Now, I hope you remember, there's a really important rule with regards to inequalities when dividing by a negative. Okay, dividing by a negative is taking the signs and it's completely changing everything around. The negative is now moving on to the other side. So everything that was negative become positive, and vice versa on the other side. So what's happening is everything's turning around, which means that my sign is going to have to do the same. So we are going to have just an x on the left-hand side. My less than or equal to sign has now turned to greater than or equal to, and negative 10 divided by negative 5 was positive 2. Okay, if you divide by a negative with an inequality, your sign turns around. Okay, and the other thing that we should always do when working with inequalities is represent it on a number line. Okay, we've got 2 on our number line. X is greater than or equal to, so I'm using a solid dot there. And if it's greater than or equal to, it's heading up the number line, and it'll head up infinitely because we haven't actually said to what point is it greater than 2, so therefore it's infinite. Okay, any real number. Okay, so what have we done? We've covered a linear equation, we've covered a quadratic, and we've had a look at a inequality. All right, I hope you remember all of those. And really what I'm just trying to do here, guys, is just remind you of all of these concepts so that you can go back and really practice them hard yourselves, okay? All right, the next type of inequality we're working with, question D, is a exponential equation. Okay, I'm going to do it over here on the side. I've got 2 times by 8 to the power of 2x minus 4. And it's equal to 4 to the power of negative 2x. Okay? Exponential equations, you cannot leave your whole numbers as they are. We have to break them down into their prime bases. Okay? So therefore, what do I mean by that? 2 is going to stay as it is because 2 is a prime number. 8 can be broken down into 2 to the power of 3, okay? That is still being raised to the 2x minus 4, so let's not forget that that is still there. 4 can be broken down into 2 squared, and that is still being raised to the negative 2x. Okay, so what you'll see I've done here as a first step is I've broken all the bases down, and now everything is working with a base of 2, which is really great. That's what we want, okay? Now let's simplify a little bit. Let's tidy up. If I raise a power to a power, I have to multiply. So these are going to get multiplied here. So I've got 2 to the power of 6x minus 12, and I have got 2 to the power of negative 4x. When I multiply bases, I add my exponents. There's an exponent of 1 sitting up there. So therefore, this is now going to become 2 to the power of 6x, and positive 1 minus 12 is going to give me negative 11, and that's equal to 2 to the power of negative 4x. Okay, so the key thing here, guys, is I have now broken everything down to having the same base of 2 on either side of my equal sign. That is then the point at which you are allowed to drop your base. The base falls away, and I'm just going to equate the exponents part of it. So 6x minus 11 equals negative 4x, okay? And that now is just a normal linear equation. We know exactly what to do with that. The 4 is going to jump over. We're going to land up with a positive 10x, and the 11 is going to move over to become positive, and we're going to divide. So 11 over 10 will be my solution there. Okay, so exponential equations, the point of those is that you want to break everything down to have the same bases. If you've got the same bases on either side of your equal sign, those will fall away, and you just work with what was in the exponents, and you can solve those relatively easily. So that's the key to an exponential equation. All right. Okay, guys, I'm sure I've given you lots of information over there, so let's take a short break to process all of that, and we'll be back soon.
All right, guys, let's take that break, and then when we come back, there's still more, so don't go anywhere. Welcome back, guys. You are still with us on the Grade 10 Mathematics Exam Revision Show, and we have Tamlin and myself. So if you've just joined us, you are a little bit late, but don't worry, because we've still got work that needs to be covered. So Tamlin will be taking us through that. Let's continue.
Okay, right, we've had a look at equations. One part which we haven't had time to do, grade 10s, is simultaneous equations, and again, really, really important, okay? So please make sure you go through the notes that are on the website, as well as your own notes. Make sure you know how to do those, okay? However, I'm going to use the time to go on to another really important section of paper 1, which is functions, okay? I know this is a section that a lot of you have a lot of trouble with. My advice to you guys is go back to the basics. Go back to the beginning, revise at least how to sketch each one of those functions, and make sure that you are clear on how to find the equation of each one of those functions, okay? The more you do of them, I really do promise, the easier it's going to become, because you'll realize that there's a very repetitive nature to these questions. So make sure you do enough questions on these. Unfortunately, they're going to come up in grade 11 as well as in grade 12. So you need to really get a good grasp on them now. Okay. All right. We've got, in this case, a parabola, okay? Here's our functional notation. F of x is equal to, remember the function of x, it's another notation for y, okay? Y being your dependent variable, is negative x squared plus 4, and it's shown below. Just a few things, because it's negative, we've got a frowning shaped parabola, so just watch out. Remember that that's always going to determine whether your graph smiles or frowns, okay? And the 4, remember, is always going to tell us where we're crossing the y-axis. So that will always be your y-intercept, which in grade 10 is always also going to be your turning point. It's the point where the graph goes from increasing to turn around, and it'll become decreasing, okay? So you've got to know those. Those are really important. Here it's asking us to give them the lengths of OA and BC, okay? O being obviously the origin at the center over there. Okay, a lot of this you can actually do without needing to do any working out. The distance from O to A. Well, O is at your origin, and we've taken 4 jumps up to get to point A. So OA is 4 units. No working out required there, okay? The length from B to C, that's a little bit more involved, a little bit more working out required. What we need to be clear on is what exactly is point B and point C, okay? What we want you to be clear on is that they are both x-intercepts. points. They're where the graph crosses the x-axis. And as I'm sure we're all rarely familiar with, if you're wanting to work out an x-intercept, you take your equation and you let y equal 0. And vice versa for the y-intercept. Okay? So my equation of this function was f of x was equal to negative x squared plus 4. So to work out these two x-intercepts, I'm going to let y equal 0. Which leaves me with what kind of equation, grade 10s? A quadratic equation. Why? Because I've got an x squared. Okay, so can you see how the sections now start to overlap a little bit? Quadratic equations come in here. What were the rules of quadratic equations? Everything had to be on either the left or the right-hand side, but one of your sides had to be equal to 0. The next step, you had to factorize what was on your, where all your variables were. Now, because this side is equal to 0, I'm going to divide everything through by a negative, giving me positive x squared and minus 4. Okay, and the negative can fall away because it's equal to 0. And we're going to factorize. So therefore, I'm going to take my x squared minus 4, which is a difference of 2 squares. And we've got x minus 2, and we've got x plus 2. Okay? That means that I'm going to land up with two answers for x. I'm going to get a positive 2, and I'm going to get a negative 2. So on my graph, where the answers are, where it's crossing each other, are at negative 2 and at positive 2. Now the question is asking, what's the length of BC? So how many units is it from point B to point C? When we're talking about length, the negative is irrelevant. We're asking literally how many jumps are there from one point to the next. So over there, I've also got 4 units. So from B to C is 4 units. Okay. All right, then this question, really common and a really nice one to make sure we understand. Determine the length of FG. Okay, here's FG. Determine the length of FG if OG is 1 unit. So they're telling me that the distance from there to there is 1 unit. Okay, so what? Okay. If the distance from there to there is 1 unit, it means that at point G, my x value is only 1 unit away from the origin, but we've got to be careful in which direction it's 1 unit away from the origin. In this case, it's 1 unit in the negative direction. So at point G, my value for x is negative 1. Okay? Now again, okay, so, all right. Well, the point is that all the way along this line FG, the x value would be negative 1. It would never ever change, okay? So therefore, what we need to work out is what would the y value be where the x value is negative 1. So we're going to take our standard equation, the one we were given in the beginning, and I'm going to work out where x was negative 1, what's y? So f of negative 1 is giving us, that's going to land up becoming positive 1, and negative 1 plus 4 is 3. So f of negative 1, so in translation, where x is negative 1, y is 3. Okay? So therefore, what is the length of FG? FG is 3 units. Okay. And one question quickly, what is the value of x if f of x is increasing? Can you see that if I go from left to right on my graph, as I go from left to right, do you agree that these y values are getting higher and getting higher and getting higher until we hit this point over here? That's your turning point. From there, the y values would get lower and lower and lower, and that would continue infinitely, okay? So working from left to right, from negative infinity all the way up to where x was equal to 0 is where your function is increasing, and then when x is from 0 to positive infinity is where it would be decreasing, okay? So therefore, my answer to that, guys, is that x is an element from negative infinity to 0, and it's increasing, and what you must be careful of is that at 0, if you were to think about a ball being thrown up in the air, as the ball gets higher and higher, there's going to be a fraction of a second where that ball actually stops. And it's not increasing, it's not decreasing, it stands still for a second, and then it would decrease. So therefore, would I include naught as a value for x for which it is increasing? No, I wouldn't, because at naught, it's not doing anything. It's not going up, and it's not going down, okay? So therefore, I'm actually going to say that it's not included, which means it's a round bracket. For which values of x is f of x greater than naught? It is greater than naught from x is -2 to where x is +2. Okay, and it didn't say including, it didn't, so therefore our brackets are round, and it's from -2 to +2. All right? And very quickly, grade 10's the domain. Remember, your domain is your x values that your graph will spread over. From negative to positive infinity would be how wide the graph is going to spread. But your range is your y values, the range of y values. It will be from negative infinity. There's no stopping it over here, but there is a stopping point there. It will go up to a maximum value of 4. So your range would be from negative infinity up to 4, and I will include 4 as a final value. Okay. All right, guys, I'm going to quickly go through our challenge question as an answer. So we're going to unfortunately not be able to do all of them. But any questions that we haven't been able to go through, they are on the website. So please go and have a look at them. Okay. Right. We had this Venn diagram, and we had quite a lot of information over here going on. So let's see if I can use some space over here as okay. First of all, a Venn diagram always gets drawn inside a rectangular box, because that rectangular box represents the full sample, okay? The full sample in this case was 200. There were 200 learners, okay? Some of them took science, some of them took history, and some of them took, what was the other one? Biology. Okay, so we've got 3 circles, and these circles are going to intersect each other, like so, all right? And right at the very bottom, it said, first of all, let the number of learners that take science and biology but not history equal x. So let's make that biology, the top one, science, and history. So the people who take biology and science but not history had to equal x. Well, that's going to have to be that space in between over there. Okay, there's your x. All right? We were told that 15 learners take all 3 subjects. 15 learners is going to have to be inside over there, all right, and where all 3 of them overlap. 190 learners take history or science or biology. Well, that's a bit tricky to work with right now, because 190 would represent all 3 circles. But what that is telling you is that if 190 took all 3, there are 10 people sitting outside who didn't do any of those, okay? 35 learners take biology and history. So biology and history is this overlap over here. That's the overlap, of which we already have 15 sitting inside there. So therefore, we're going to have 20 in that space. 23 take history and science, of which 15 are already there. So 23 minus 10 is 13, minus 5 is 8. So we're going to have 8 learners sitting over there. 90 learners take biology. Now, 90 learners take biology means the whole circle of biology, okay? So if 90 is the total, then what's left in this space over here is going to have to be 90 minus the x as well as the 15 and the 20, so minus the 35, okay? I'm just going to leave that like that for now. And 63 takes science, same thing. We're going to have to say 63 minus x minus 23. And 107 take history, so therefore same thing, 107 minus the 3 overlapping values there, so minus 20, minus 8, minus 15. And that then is your complete Venn diagram. Okay, so I hope you guys managed to get that. And if you didn't, again, please go over the notes. Very, very possible question, especially because it's new in your syllabus. So as teachers want to test you on it, okay? Guys, I hope you learned a lot. Definitely lots more to go and revise, so please make sure you do, and I will see you next week for paper 2.
Wow, thank you so much, Tamlin. And thank you, Mindsetters, for attempting the challenge question. I can see a few of the answers, and you guys are almost there. You
Fantastic,
guys
well done.
almost got it right. So
The most
that is,
important thing is to try. That is definitely.
yes, that is definite. Always try. Never leave a question out, guys. At least write something. You never know, you could actually get marks out of it. That is something that I learned in high school.
Absolutely.
And it always worked for me. Sometimes I'd actually get the question right and I'm like, oh wow, I didn't even know that.
Yeah, that's for sure.
Well, thank you guys so much for tuning in with us. Thank you,
It's a
Tamlin.
pleasure. Thank you for having us.
We'll see you guys next week for paper 2. So remember, come back. We will be here for you guys next week, same time, same place. Goodbye.
Bye.